You are the last one. Not metaphorically, actually the last. Every cousin you ever had is gone, and you don't fully understand why. That was the situation Homo sapiens found itself in by roughly 30,000 years ago, and nobody sent a memo explaining it. Extinction doesn't usually look like a war. It rarely looks like a single bad day. What it actually looks like, if you study it closely enough, is a pattern, the same ingredients showing up again and again, in different combinations, until a population simply can't recover fast enough to keep existing. We're going to trace that pattern through 4 species. Not because their stories are similar on the surface, they're wildly different, separated by continents and hundreds of thousands of years, but because underneath, the mechanism keeps repeating. And once you see it, you can't unsee it in our own story either. Start with a Homo erectus population that ended up trapped on the island of Java. Homo erectus is, by any measure, the most successful human species that ever lived, nearly 2 million years on the planet, longer than every other human species combined, longer than most mammal species survive as a whole. They outlasted ice ages, they outlasted continental droughts, they outlasted climate shifts that would have ended most species several times over. But longevity isn't immunity. Their final population had nowhere left to go. Cut off by water, with the mainland out of reach and the forest shrinking around them, they weren't fighting a predator or a rival. They were fighting geography, and geography doesn't lose. Their last fossils date to around 108,000 years ago, found at a site called Ngandong. A species that had survived longer than any other human lineage in history didn't go out in a blaze. It just ran out of room. There's something worth sitting with here. A population can be perfectly adapted to its environment and still be doomed the moment that environment stops changing along with it. Isolation doesn't announce itself as a crisis. It looks, for a long time, like stability. Right up until it doesn't. Now go to the Denisovans, a species we know so poorly that for years, most of what we had was a finger bone recovered from Denisova cave in Siberia. Researchers led by Svante Pääbo sequenced DNA from that fragment in 2010 and found something that matched nothing on record, not Homo sapiens, not Neanderthals. A new branch, hiding in plain sight in a single bone. Here's the strange part. Even with almost no fossils, Denisovan DNA is loud in the present. Some populations in Papua New Guinea carry around 5% Denisovan ancestry. A gene called EPS1, inherited from Denisovans, helps Tibetan populations survive at altitudes where oxygen is thin enough to kill an unadapted body. A species we can barely find in the ground is still, quietly, keeping people alive today. So how does a species leave that much of a genetic fingerprint and still vanish? Genome studies suggest Denisovan populations were already small and fragmented before Homo sapiens ever arrived in the region. Small populations lose genetic diversity fast, and low diversity makes every disease, every bad season, every hard winter more dangerous than it would be for a larger group. They weren't erased in a single event. They thinned out, generation after generation, until there weren't enough of them left to keep being a population in any meaningful sense. This is the part that's easy to miss if you're only picturing one big catastrophe. Most extinctions don't look like a comet. They look like a slow leak. Then there are the Neanderthals, the species this pattern is hardest to explain because they weren't primitive, and they weren't unprepared. Their toolkits were sophisticated. Their bodies were built for cold, brutal environments, with wide chests and dense bones suited to close-range hunting of large, dangerous animals. Some sites show evidence that they cared for injured group members who couldn't have survived alone otherwise. A Neanderthal skeleton found in Shanidar Cave in Iraq shows healed injuries so severe the individual would have needed sustained help from others just to stay alive. For several thousand years, Neanderthals and Homo sapiens occupied the same landscape across Europe and Western Asia. We know they interbred. Most people with non-African ancestry today carry somewhere between 1 and 2% Neanderthal DNA. That's not the story of two species that never crossed paths. That's the story of two species competing for the exact same deer, the exact same shelter, the exact same river valleys, generation after generation. Homo sapiens had one advantage that mattered more than brain size or muscle: bigger, more connected social networks. When a Neanderthal group lost a bad season's worth of hunters, they were largely on their own. When a Homo sapiens group lost the same, there was often another group nearby to trade with, marry into, or fall back on. Over centuries, that difference compounds. It doesn't need to be dramatic in any single generation. It just needs to be consistent. By around 40,000 years ago, the Neanderthal fossil record goes quiet. There's a fourth piece to this pattern, and it comes from an island most people have never heard of. In 2003, researchers on the Indonesian island of Flores uncovered the remains of a human species barely a meter tall, with a brain roughly the size of a grapefruit. For a while, some scientists assumed the bones belonged to a modern human with the disorder. But the evidence kept accumulating, and it became clear this was something else entirely: Homo floresiensis, an isolated population that had evolved in miniature. Islands do strange things to bodies over enough generations. Large animals often shrink, small animals sometimes grow, and populations reorganize around whatever the island can actually support. Homo floresiensis lived alongside Komodo dragons and dwarf elephants, in an ecosystem that had rewritten its own rules. Their fossils run from roughly 100,000 to 60,000 years ago, with stone tools suggesting a presence that may have lasted until around 50,000 years ago, right around the time Homo sapiens was moving through the region. You don't need a catastrophe to end a species like this. On a small island, with a population that was never large to begin with, a single new pressure, a shift in food supply, a new competitor, a change in climate can be enough. Small worlds don't have much room for error, and Homo floresiensis was living about as close to the edge as a human species can live. Here's what those four stories have in common, and it isn't a villain. Homo erectus didn't lose a war. Denisovans weren't hunted down. Neanderthals weren't simply worse at being human. Homo floresiensis wasn't a failed experiment. Each of them ran into some version of the same wall: isolation, shrinking numbers, competition without enough of a support network, or a world too small to absorb any shock at all, and none of them had every one of these problems solved at the same time. It's tempting to reach for intelligence as the explanation for why we're still here and they aren't. But that falls apart almost immediately. Neanderthals were intelligent. Denisovans adapted to some of the most extreme environments on the planet. Homo erectus outlasted us several times over already, and we haven't even come close to matching that record yet. Homo floresiensis survived conditions that would break a modern person within days. What actually set Homo sapiens apart was something less flattering and more structural. We didn't dodge these problems because we were smarter. We dodged them because we kept building connections between groups that had no obvious reason to help each other: trading routes stretching hundreds of miles, shared toolmaking knowledge, wide genetic mixing across populations that had never met. When a crisis hit one group, the knowledge that group carried didn't have to die with them, because it had usually already traveled somewhere else. When the climate shifted and entire regions became unlivable, we had the flexibility to reorganize, because we were never locked into a single place or a single strategy the way an isolated island population was. Even that only explains part of it, though, and it's worth being honest about the rest. Luck mattered. Geography mattered. Simply having enough people in the right place at the right moment mattered. We weren't destined to be the last one standing. We just happened to be, and it's worth remembering that. Happened to be is doing a lot of quiet work in that sentence. Every other human species solved survival brilliantly for a while, some of them for far longer than we've managed so far. Homo erectus held on for 2 million years and still ran out of room. Neanderthals endured ice ages that would break most modern infrastructure, and still couldn't outcompete or rival with better logistics. The Denisovans left behind almost nothing in the ground, and yet pieces of them are still written into the lungs of people living at altitude today. Homo floresiensis carved out an entire miniature existence on a single island, and it still wasn't enough once the world around them started shifting. We just solved it for longer. Not because we were the strongest branch on the tree. Because we were the branch that never let go of the other branches, and there's no guarantee that advantage lasts forever either.